Hello, welcome to lesson 1.5. Today we're going to work on extending our solving to be able to solve absolute value equations. Well, hopefully that brings up a good question. The first thought should be, okay, well, what's an absolute value? So I want us to consider what an absolute value is by consider solving the most simple absolute value equation that we can come up with. If I tell you the absolute value of x is equal to 5, could we solve it? Well, let's dive into what the definition of an absolute value is. What is an absolute value? The definition is it's really just the measure of a number from 0. So it's the measure of distance, the distance. Oh, I'm mixing the words the and distance together. Let me try this again. Of the distance of a number from 0. And I think maybe thinking of number lines would probably help us some here. So if I were to draw a number line, and we're saying x, the distance of x from 0 is 5. Well, I know everybody and their mama knows that the number 5, if I were to count 1, 2, 3, 4, 5, everybody knows that 5 is 5 from 0, right? 1, 2, 3, 4, 5. That's its distance from 0. Okay. Well, I have a question for you. Distance is only measured positively. So even if you run to your grandma's house and it's 2 miles, and then you run back, you still travel 2 miles. Even though it's in the opposite direction, the direction doesn't matter when it comes to distance. You still covered 2 more miles, no matter which way you ran. Even if you ran backwards, you covered 2 miles. So that means that this has a distance of 5 away. But there's another number that has a distance of 5 away from x. 1, 2, 3, 4, negative 5. Negative 5 is also 5 away from x. 1, 2, 3, 4, 5. Huh. So 5 and negative 5 both have the same distance from 0. So if I'm trying to figure out which number has a distance of 5 from 0, this gets a bit tricky because there's 2 of them. Wait a second though. When we go to solve these absolute values, then we're always going to consider the 2 cases, that it could be either direction from the 0. So what I'm telling you here is you're going to come out with 2 possible answers. Okay, so if I were solving this very simple absolute value equation, I would come up with the answers that x is equal to 5, or it's possible that x is equal to negative 5. And I'm going to get 2 answers. So every time we go to do these problems, we're going to need to consider or break the equations that we're solving into 2 cases. Okay, so kind of to lay out some steps here of how we're going to do this, to be able to solve absolute values, let's say steps. The first thing we're going to want to do is you're going to want to first get the absolute value, whatever's in there, I don't care, all by itself equal to some number. Okay, I don't want any numbers on the outside. Okay, so if there are numbers on the outside, we're going to have to use algebra to get them moved over to cancel them out. So I need an absolute value with stuff in there. It doesn't matter what's in there, but an absolute value equal to a plain number. Then step 2 is we're going to break it into 2 cases and solve the 2 cases. So solve the 2 cases that it could be equal to the positive or the negative of whatever this number is. Okay? Now, this will make much more sense when we do an example. So let's do an example right here beside my 2 steps to see if we can this might be too easy of an example, but let's do it. So we'll start with an example like this. Absolute value of x, close your absolute value, plus 7 equals 10. All right, now I'm looking at my steps here, and I need absolute value equals a number. I have absolute value plus a number equals a number. So what thing is in the way of me having what I need for step 1 is this plus 7. I can't have any numbers outside the absolute value on this side of the equal sign. I need to move them over. That's okay. We know how to do this. How do I get rid of a plus 7? I'm going to subtract 7 from both sides. So the absolute value of x is equal to 10 minus 7 is 3. Nice. That's really simple. And then step 2 says solve the two cases. Or what are the two cases? So the way we break it into two cases, I'm going to be annoying and write two cases every time I do this, is one case is to just drop the absolute values and take it as is. X equals 3. The other case is to drop the absolute values and set it equal to the opposite or the negative of this number. So equal to 3, so the opposite of 3 is negative 3. And then we will solve these two. Well, luckily for us, these are already solved because this is a very simple example. So the two answers are x equals 3, and the other answer is x equals negative 3. Nice. Okay. Well, let's kind of step it up a bit. Let's do an example that maybe has different things we need to worry about. One like this: the absolute value of 2x plus 5, close absolute value equals 11. So if I'm thinking of my two steps, I need to get rid of anything on the outside of the absolute value. Well, looky there. We don't have anything outside. That's really nice. We can just jump into our two cases. Okay. One case is going to be 2x plus 5 is equal to 11. In the other case, 2x plus 5 is going to be equal to negative 11. So once again, notice that the left side, where our absolute value is the same in both cases. The only difference is the right-hand side is going to be 11 and negative 11. Those are our two cases. So now I need to solve each case, and I'll have my two answers. So plus 5, to get rid of that, I'll minus 5. And so 2x equals 11 minus 5 is 6. And then this shouldn't be too hard to solve from here. Divide both sides by 2. And x equals 3. Okay. Or let's do the other side. All right, subtract 5. Be very careful here. A lot of people notice, hey, it's the same steps. I'm going to subtract 5 and divide by 2. But they forget to pay attention to the fact that this is a negative 11, so be very cautious. So 2x, 5 minus 5 is gone, equals negative 11 minus 5 is negative 16, actually, right? And so then when I divide both pieces by 2, I don't get the same answer as the other one. I get x is going to be equal to negative 8. So I got the answers 3 or negative 8. Okay. Well, that's still not too nasty. Let's try another example. We'll go with absolute value 3x plus 6, close your absolute value, minus 9 equals 30. So this is kind of combining the two things we had to do from the last two problems. First off, you look, can I break it into its two cases yet? And the answer is no, because the absolute value is not all by itself. I have this plus or minus 9 in the way. Well, that's not hard. We know enough algebra from our first lesson to be able to solve things. I know how to get rid of a minus 9. I just need to add 9 to both sides. And that minus 9 is gone. So then I have 3x plus 6 is equal to 39. Well, now I'm ready for my two cases. I just need to split it into the two cases. So 3x plus 6 equals 39, or 3x plus 6 equals negative 39. Once again, a lot of people have a hard time writing these cases. One is just dropping the absolute values, and the other is almost the same. I just make this right-hand side negative. All right, so let's solve these now, and I'll go kind of quickly on the solving. Subtracting 6, so 3x is equal to 33, and divide both sides by 3. And when you do that, you'll get our first answer is x is equal to 11. Nice, let's do the other side. Subtracting 6, 3x is equal to negative 39 minus 6. What's that going to be? That's going to be negative 45. And then when I divide that by 3, I'm going to get x is equal to negative 15. Nice. A positive 11 and negative 15 are our two x values. Okay. I have one more example for you that doesn't quite fit this technique because all of these have had just one absolute value. What happens whenever I give you two absolute values like this? Just want to show you one example of this. So 3x plus 4 equals, so that's an absolute value, equals absolute value 2x plus 11. Now we can get really nasty with this and have numbers outside and inside and all over the place, but the highest level difficulty we're going is no numbers on the outside, absolute value equals absolute value. So this is simple. So we look at this, and this is the best we can do to get absolute value equals a number. This is not perfect, but it's the best we can do. So what we're going to say here is, okay, we're ready for our two cases. How am I going to write these two cases? Well, the first case, just drop your absolute values. 3x plus 4 is equal to 2x plus 11. Okay, I think I can do that. What's my other case going to be? Well, we're still going to leave the left side alone like we always do. 3x plus 4 equals, and we're just going to do the opposite of the right side here. So if something's negative, it becomes positive. If something's positive, it becomes negative. So the opposite would be negative 2x minus 11. Make sure you take the opposite of both terms of the entire expression over here. Okay? And that gives us our two cases. And now we can go about solving. I need to get my x's on the same side. So subtract 2x from both sides. 3x minus 2x is just 1x. And now I can finish solving. Subtract 4, x is equal to 7. And now let's solve the other side. I'm going to add 2x to both sides to get rid of a minus 2x. So I get 5x plus 4 equals negative 11. I'm going to subtract 4 from both sides. And I have 5x is equal to negative 15. Almost there. Now I got to divide both sides by 5. And x is equal to negative 3. So I have 7 or negative 3 as my two x values. Okay, so that's as convoluted as it gets as we give you one with two absolute values. And we won't be very mean. We could be evil and put them on the same side, throw some extra numbers in to make this. But this is as hard as we're going to go on this difficulty level, as absolute value equals absolute value. And the two cases are just one, drop the absolute values, that's one case. And the other one is we always just opposite this right-hand side. So it was positive, positive, so it's going to be negative, negative. If it were negative, negative, it'd be positive, positive. Whatever it is, you do the opposite of the right-hand side. Okay? Well, that's all I have for you. Good luck on the work. And that's the last lesson in this chapter. So good luck on test 1.